Hello, this is Mr. Collier, and today we're solving some linear inequalities. Okay, we're going to start with this fraction one here. What we want to do first when we have a bunch of fractions is to multiply to clear the fractions. So we're going to multiply both sides by 6, so that's the common denominator, and you get x minus 9 is less than 4x. And then we can subtract. So it's just like a regular equation for the most part. We get negative 9 is less than or equal to 3x, and I can divide by 3. And if you divide or multiply by a negative number, you have to flip the inequality, but that's not the case here. So we have this. I'm going to rewrite it like so: x is greater than negative 3. So we can graph that, and we put negative 3 in the middle. And to the right we have these numbers, maybe a couple to the left. And since this is not including negative 3, we need to indicate that with a circle, and then you can shade, wrong way, then you can shade greater than negative 3 is this way, or some people like to draw it above the number line. Okay, next example, we're going to look at some compound inequalities. And we have this statement: x plus 3 is less than or equal to 2, or negative 5x is less than negative 10. So we just solve them independently. So I'm going to subtract 3. We got x less than or equal to negative 1. Or now here you're going to divide by negative 5. When you divide by a negative number, you flip the inequality sign, so we have x is greater than 2. So then we can get our number line. And obviously negative 1 is going to be important, and 2. So x is greater than 2, we do a hollow dot and this way. And for less than negative 1, we do a solid dot because it includes negative 1. And we go to the left, which is less than. Okay, and if we have an and inequality, let's solve those independently again. So we have plus 3. X is less than or equal to 5, and then for here we're going to have x is greater than or equal to 2. Okay, now so if x is less than or equal to 5 and greater than or equal to 2, then I'm going to start with 2 and then do 3, 4, 5. We'll put both solid dots, and what you get is just color the number line in between. Okay, so that represents every single number between 2 and 5, including 2 and 5. And there's another way we can write this. We can write this as one compound inequality. X is greater than or equal to 2, less than or equal to 5. So usually we write the answer like this. And I should introduce these symbols. This is the conjunction or and symbol. So we can use and here instead of the word and. And this one is for or, so we could use that one there instead of the word or. Oops. Okay, we'll use more of that later. Okay, next we have this one here. Okay, so if you got something like that, you can work with all 3 parts of the inequality at the same time. Okay, so first thing we want to do is add 9, and we add it in 3 different places. So we have 4 less than 2y less than or equal to 14. Then we divide by 2, and we get 2 less than y less than y less than or equal to 7. Okay, and then we can draw that number line 2, 3, 4, 5, 6, 7. This one's hollow, this one's solid, and then you shade in between. Okay, next we have a couple absolute value inequalities, and we're just going to look at the number line first to think about this logically. Okay, so what numbers for x would give you an absolute value less than 5? Well, the absolute value of 0 is less than 5. Absolute value of 1 is less than 5, 2, 3, 4, 4.5. So all these numbers, if you absolute value them, they're less than 5. But also negative numbers up to negative 5. Okay, so that would not including negative 5. So if you had negative 4 and you absolute value it, you also get a number that's less than 5. So this is the solution set on the graph. So you have x is less than 5, greater than negative 5. Okay, so similarly with this one, you're going to get n minus 2 is less than or equal to 5, greater or equal to negative 5. And then you can add 2 to both, or each part of the inequality, and you get negative 3 is less than or equal to n, less than or equal to 7. Okay, so you got 7 here, and then negative 3, solid dots, and everything in between. Okay, and similarly for this one, you're going to have less than or equal to 14, and greater or equal to negative 14. So I'm going to subtract 6. We got negative 20, less than or equal to 4t, less than or equal to 8. Divide by 4, and we get negative 5, less than or equal to t, less than or equal to 8/5. Okay? Or 8/4, so that's 2, sorry. So we have 2 here, 1, 0, 1, 2, 3, 4, 5. Solid dots on both of them.